This topic is complex conjugates and dividing by two complex numbers. In this box it says, what are complex conjugates? If I have a complex number, a plus bi, notice this term in front of the bi is a positive. Its conjugate then is changing that imaginary part to its opposite side. So be a negative. So these are considered complex conjugates. So the example says is, give the complex conjugate of 3 plus 5i. So we look at this sign, it's a plus, so we now change that to a minus. So the complex conjugate is 3 minus 5i. Let's see what happens when we multiply conjugates together. So I'm going to multiply this red piece to this purple piece. Let's see what happens. So we take 3 plus 5i, and we multiply it to 3 minus 5i. We're going to remember, when you multiply two complex numbers together, think of that method as foiling. So we do first, 3 times 3 is 9. Then we do outside. 3 times negative 5i is negative 15i. Then we'll go to inside. 5i times 3 is positive 15i. And then we'll go to last. 5i times negative 5i is negative 25i squared. Do some simplifying. Remember, I squared can be replaced with a negative 1. Negative 25 times positive, or negative 1 is a positive 25. And now notice what happens with the blue and the black. Negative 15i plus 15i cancels out. And then we have this green piece of the 9. 9 plus 25 is 34. What always happens with complex conjugates is the middle terms will always cancel out. So you only have to worry about first and last. So that's leading us to this example. What we're doing is we are taking a complex number and dividing it by another complex number. When you do that, to be able to simplify it, it's kind of like what we have to do when we rationalize the denominator. If you remember, if I give you an example like this, 5 over 3 plus the square root of 2. If you wanted to rationalize it, you would say 3 minus the square root of 2 and 3 minus the square root of 2. We've done that already this year. We need to multiply by the denominator's complex conjugate. I'm just going to erase this now. We don't need that. So if I look at the denominator right here, I want to multiply by its complex conjugate. So what is the complex conjugate of that? It's 3 plus 4i. So we're going to multiply that original fraction by 3 plus 4i over 3 plus 4i. Now we have that original green. I'll just color this in green here, and then in blue. All right, what we have is a fraction times a fraction. We have some foiling to do. So we're going to FOIL the numerator. So 3 times 3 is 9. 3 times 4i is 12i. I'm going to just erase those arrows. So we've done first in, outside, go to inside. 2i times 3i is 6i. 2i times 4i is 8i squared. Over, and now we have to FOIL the denominator. And I'm going to do the entire FOIL, even though we know that complex conjugates, middle terms cancel out. I'm going to show that they will. So 3 times 3 is 9. That's first. 3 times 4i is 12i. So we've done first in, outside. Inside, negative 4i times 3i is negative 12i. And then negative 4i times 4i is negative 16i squared. Do some simplifying. notice that these middle terms do cancel out because we multiply by complex conjugates. 12i minus 12i cancels. I have like terms here of 18i plus 9. And then this I squared is replaced with a negative 1 over 9. This I squared is replaced with a negative 1. Continue simplifying. Nine plus 18i. Purple, 8 times negative 1 is negative 8. Negative 16 times positive, or times negative 1 makes it a positive 16. These are like terms. 9 minus 8 is 1. We have minus 18i. 9 plus 16 is 25. Now just break up this fraction. 1 over 25 minus 18i over 25.